Welcome to McDaniel College's training presentation on OSHA's Hazard Communication Standard. Purpose of OSHA's Hazard Communication Standard. The Occupational Safety and Health Administration, or OSHA, is responsible for ensuring safe and healthful working conditions within the United States. OSHA's Hazard Communication Standard, or HazCom, is also known as the Right to Know Act. This standard can be found in Title 29 of the Code of Federal Regulations, or CFR, under Part 1910.1200. It ensures that employers and employees know about hazards in the workplace and how to protect themselves so that the incidence of illnesses and injuries due to hazardous chemicals is reduced. You have both a need and a right to know the hazards and identities of the chemicals you are exposed to when working. You also need to know what protection is available to keep yourself safe and healthy. Who is covered? The HazCom standard applies to general industry, shipyard, marine terminals, longshoring, and construction, and covers chemical manufacturers, importers, employers, and employees exposed to chemical hazards. Some employers who fall under this category here at McDaniel College include art, theater, physical plant, grounds, mail services, custodial, and more. A hazardous chemical is any chemical which is a physical or health hazard. Office workers who encounter hazardous chemicals only in isolated instances are not covered by the standard. OSHA considers most office products, such as pens, pencils, and adhesive tape, to be exempt under the provisions of this rule. OSHA has stated that intermittent or occasional use of a copying machine does not result in coverage under the rule. However, if an employee handles the chemicals to service the machine or operates it for long periods of time, then the standard would apply. Who is not covered? Employees who use hazardous chemicals in their work are covered by either the HazCom standard or the Laboratory Safety Standard, also known as the Chemical Hygiene Plan. All individuals or groups, including all academic laboratories and research laboratories, are covered by the Laboratory Safety Standard and are therefore not covered under the HazCom standard. Art studios and theaters have the option to choose which standard to fall under, and here at McDaniel are covered under the HazCom standard. The HazCom standard has a few exceptions for individuals working with food, food additives, wood and wood products, pharmaceuticals, and pesticides, where these are covered under other regulations. If you work with any of these products, please check with your supervisor to determine if additional training is required. Employer responsibilities. It is the responsibility of the chemical manufacturers and importers to review scientific evidence on the hazards of chemicals they produce or import, and report findings to their employees and to employers who distribute or use their products. Employers are responsible to identify and list hazardous chemicals in their workplaces, meaning inventory these chemicals, prepare and implement a written plan and program, and make sure all containers are properly labeled, obtain safety data sheets, known as SDSs, provide training, and communicate all hazard information to employees. Employee responsibilities. As an employee of McDaniel College, it is your responsibility to perform work in the safest manner possible and follow all college policies and procedures. Report any health or safety hazards to your supervisor or the appropriate department based on the hazard. When in doubt, contact campus safety for assistance. It is the responsibility of the supervisor to continually train their staff in all college policies and procedures. Written HazCom program requirements. There are specific requirements for a written HazCom program. The written program must incorporate the following: describe container labeling, safety data sheets, and employee training for each workplace. The written program must also describe the method for listing all hazardous chemicals in the workplace and make information regarding hazards and protective measures available to all employees. The written program is required to help ensure that all employers receive the information they need to inform and train their employees and to provide necessary hazard information to employees. The Globally Harmonized System, GHS. There have been some changes over the years to the Hazard Communication Standard to help align the United States with the rest of the world and ensure that the OSHA Hazard Communication Standard is consistent with the United Nations Globally Harmonized System of Classification and Labeling of Chemicals, or GHS for short. The major changes that affect us in the United States are the way we classify hazards, specific requirements for labeling chemicals, and the format of our safety data sheets. Hazard classification, previously known as hazard determination, provides specific criteria for classification of health and physical hazards, as well as classification of mixtures. With regards to labeling, chemical manufacturers and importers are now required to provide a label that includes a harmonized signal word, pictogram, hazard statement for each hazard class and category, precautionary statements, supplier identification information, and product identifier. Lastly, material safety data sheets are now known as safety data sheets and follow a specific 16-section format. Safety data sheets. Safety data sheets, just as material safety data sheets, explain all of the necessary information for the chemical being used. The information on the safety data sheets, or SDSs, must be presented using specific headings in a specified sequence. The format is the same as the American National Standard Institute, or ANSI, standard format, which is familiar to many U.S. employees. SDSs must be written in English and located in the areas where hazardous materials are being used and/or generated. SDSs must be readily accessible to all employees during all work shifts, either in binders or through 24/7 electronic access. Here at McDaniel College, we have binders located in a number of work areas throughout campus. Ask your supervisor where the SDSs related to your work are located if you do not already know. There is also an electronic system called Chimera for all McDaniel employees. You can access the online system via the link found on the McDaniel portal. Contact Risk Management/Environmental Health and Safety for questions regarding Chimera. Chemical Inventory. Chimera not only serves as our SDS database, but also is used as our chemical inventory system. The chemical inventory is a collective list of all chemicals here at McDaniel College. Barcodes are placed on all chemicals as they arrive to campus to ensure we know where every chemical is located, and then an SDS is attached to that chemical in the inventory system. The chemical inventory is constantly updated as chemicals are purchased or disposed of, and a full reconciliation is conducted on a yearly basis. It is important that all barcodes are removed from a chemical container prior to disposal of that container. Barcodes should be given to the department's Chimera manager for removal from the system. The inventory is also submitted to the local fire department to ensure accurate and safe response in an emergency situation. Manufacturer container labeling. The other major change to the Hazard Communication Standard under the GHS system concerns the way manufacturers must now label chemicals. Under the old chemical labeling standards, chemicals could just include the chemical name and hazard or hazards. Under the GHS chemical labeling requirements, chemical labels that are purchased from the manufacturer must include product identifiers, supplier identification, signal word, hazard statement or statements, precautionary statement or statements, and pictograms. The picture on this slide shows a sample of what a label under the new GHS compliant hazard communication standard might look like. Let's look closer at each labeling requirement on the next few slides. Product identifier and supplier identification. One of the requirements of the new labeling system is to include the product identifiers. These are the names or numbers used on a hazardous product label or on a safety data sheet. They provide a unique means to identify the chemical substance or mixture. Another requirement is to have the supplier identification information on the label. This must include the name, address, and telephone number of the manufacturer or supplier of that substance. Signal words. Having a signal word on the label is another new requirement. A signal word is one word used to indicate the relative severity of the hazard and alert the user to a potential hazard on the label and safety data sheet. GHS includes two signal words: warning for less severe hazard categories and danger for more severe hazard categories. Lower categories of classification and unclassified products would not require pictograms or signal words under the GHS compliant hazard communication standard. The current Environmental Protection Agency, EPA, system includes a third signal word, caution, that you may still see on some products. Hazard statements. Another requirement of the new labeling is to include hazard statements. This is a phrase assigned to each hazard class and category that describes the nature of the hazard. Examples of hazard statements that you may see on a chemical container include: may be fatal if swallowed or enters the airways, may cause an allergic skin irritation, fatal if inhaled, may cause drowsiness or dizziness, harmful to aquatic life. Precautionary statements. Precautionary statements must also be included on the new labels. These are phrases that describe recommended measures that should be taken to minimize or prevent adverse effects resulting from the exposure to a hazardous product or improper storage or handling of a hazardous product. The four types of precautionary statements include prevention, response, storage, and disposal. Pictograms. The last of the new labeling requirements are adding pictograms to the labels. A pictogram is a symbol with other graphic elements, such as a border, background pattern, or color that is intended to convey specific information about the hazards of a chemical. There are 9 pictograms under the current GHS-compliant hazard communication standard to convey the health, physical, and environmental hazards, as you will see on the next slide. For transportation labeling, Department of Transportation, or DOT, approved hazardous materials placards should still be used. Where a hazardous materials placard appears, the GHS pictogram for the same hazard does not have to appear. The picture on the top right of this slide shows containers labeled with pictograms. The picture on the bottom shows some of the DOT placards still used in shipping and transportation. There are 9 pictograms under the GHS-compliant hazard communication standard. They convey the health, physical, and environmental hazards of the chemical at hand. This picture shows the chemical bottle labeled in accordance with GHS requirements. This chemical bottle is then placed inside of the box that remains under DOT regulations using the DOT hazardous materials placard. Proper labeling under the GHS system. In this slide, you can see a sample label with all of the new labeling requirements as discussed in the previous slides. Other OSHA requirements. In addition to GHS hazards, OSHA requires additional information regarding simple asphyxiants, pyrophoric gases, and hazards not otherwise classified. Simple asphyxiants should be labeled with the following statement: warning, may displace oxygen and cause rapid suffocation. Pyrophoric gases should be labeled with the following statement: danger, catches fire spontaneously if exposed to air. Hazard not otherwise classified does not need to be addressed on the labels, but must be addressed on the SDSs. NFPA 704 diamonds. The National Fire Protection Association, or NFPA, uses a system to help identify the hazards of a chemical called the NFPA 704 diamond. This system is utilized by all first responders in the United States and can be found in a number of locations that you visit regularly, such as the gas station. The top picture on this slide shows the NFPA diamond providing hazard information for the cage of propane tanks. You will see the NFPA 704 diamonds around campus in such areas as the laboratories and facility areas. The bottom picture describes how to read and fill in the NFPA diamond. The diamond has 4 sections to it, each signifying a different type of hazard. Red is for fire, blue is for health, yellow is for reactivity, and white is for specific or specialty hazards. A rating of 4 is the most hazardous rating, whereas a 0 is the lowest. The white part of the diamond will be filled in with a symbol, such as the ones you see in the picture. If there is no symbol associated with the chemical, the white section will be left blank. To determine the ratings for a chemical, you can look up that chemical in Chimera. If you are filling in the diamond for 2 or more chemicals, look up both chemicals and take the highest number for each color. As an example, if you have a mixture of acetone and isopropanol, you would look up both chemicals in Chimera. Since acetone has ratings of 2 for health, 3 for fire, and 1 for reactivity, and no symbol for the specific hazard, and isopropanol has ratings of 1 for health, 3 for fire, 0 for reactivity, and no symbol for the specific hazard, the NFPA diamond would be filled out with a 2 for health, 3 for fire, 1 for reactivity, and the specific hazard would be left blank since there are no symbols associated with either chemical. Next, you would write both chemical names in the space provided for the chemical contents. Chemical storage guidelines. All chemicals must be labeled, even when they are in storage. You must always store chemicals by their hazard class, not alphabetically. Hazard classes include flammables, acids, bases, toxics, oxidizers, and non-hazardous chemicals. If you would like to arrange chemicals alphabetically within their hazard class, that is acceptable. When separating chemicals by hazard class, you are minimizing the risk of accidentally mixing incompatible chemicals together that could cause a reaction. Ensure all caps and lids are tightly closed, and never store chemicals under sinks or on top shelves that are too close to the ceiling or a sprinkler head. Never keep expired chemicals, as the college may be fined by a government agency. If you have any question regarding chemical storage, ask your supervisor or contact Risk Management/Environmental Health and Safety. Cylinder storage. Cylinders present many hazards that most people do not think about, including risk of explosion, reaction, displacement of breathing air, and even sudden decompression that can propel the cylinder across the room and potentially through the wall. For these reasons and more, it is important to store cylinders according to the regulations. Cylinders should always be secure with straps or chains connected to a wall bracket or fixed surface. They should always be stored upright, separated according to compatibility of hazard classes, and stored in cool, dry, well-ventilated areas. When a cylinder is empty or not being used, ensure that the valve is closed. Cylinders may not be transported in personal vehicles to, from, or around campus. If they are being transported in a college vehicle for specific and approved work, they must be secured to the vehicle in an upright position and should not be left outside for long periods of time. If you have further questions about cylinder safety, ensure you ask your supervisor or contact Risk Management/Environmental Health and Safety. GHS Hazard Classification. The last change brought about by the GHS system has to do with how we classify hazards. Hazard classification, similar to hazard determination in previous HazCom standards, is based on the full range of available information for that hazard. Specific criteria for classification of health and physical hazards, as well as classification of mixtures, have been established. This will help to ensure that evaluations of hazardous effects are consistent across manufacturers, and labels and safety data sheets are now more accurate. Physical hazards. According to the GHS hazard classifications requirements, physical hazards are chemicals for which there is scientifically valid evidence that it falls into one of the following categories: fire hazard, explosion hazard, or reactive hazard. Fire hazards consist of such chemical classes as flammable liquids, flammable gases, and oxidizers. Explosion hazards consist of compressed gases and explosive chemicals. Reactive hazards consist of organic peroxides, unstable or reactive chemicals, and water-reactive chemicals. Health hazards. Chemical exposure may also cause or contribute to many serious health effects, such as heart ailments, central nervous system damage, kidney and lung damage, sterility, cancer, burns, and rashes. Under GHS hazard classification, health hazards are chemicals for which there is statistically significant evidence based on at least one study conducted in accordance with established scientific principles that acute or chronic health effects may occur in exposed employees. Health hazards are separated into two categories: systemic effects and target organ effects. Some examples of systemic effects include the following chemical classes: carcinogens, toxic agents, and corrosives. Some examples of target organ effects include the following chemical classes: reproductive or genetic toxins, neurotoxins, which affect the nervous system, and agents that target the lungs, skin, eyes, blood, or mucous membranes. Protecting yourself against these chemicals and all chemicals is very important to ensure your safety and health. Hazardous materials entry routes. Hazardous materials can enter the body in 4 different routes. Materials can enter through inhalation, which happens when you breathe in the chemical and is the fastest way into your system. It is important that you understand what chemicals are being used when entering a room, as some chemicals are odorless and can overcome you very quickly. Absorption occurs when a chemical is absorbed through the skin or eyes. This is why it is important to wear the proper personal protective equipment when required. Ingestion occurs when swallowing the material. Many people do not think about washing their hands after working with chemicals. But what if you had a microscopic hole in your gloves that you did not know about and you did not wash your hands before lunch or before heading home to your loved ones? It is important to think about these types of scenarios to ensure that you keep yourself and others safe. Injection, which penetrates through the skin, can occur if a contaminated sharp is thrown into the trash and a custodial worker goes to empty the trash. Ensure proper storage and disposal of all sharp material in your area. So how can workplace hazards be minimized? The first step in minimizing workplace hazards is to perform a thorough hazard assessment of the workplace to determine where the hazards are. Hazard assessments will be conducted by risk management/environmental health and safety on an annual basis or when a new hazard is introduced into the workplace. This process will evaluate all hazards for that specific job, including but not limited to chemical use, personal protective equipment requirements, equipment and tools utilized, and more. With regard to the assessment of chemicals in the workplace, employers can rely on the evaluations performed by the manufacturers or importers to establish the hazards of the chemicals they use. This information is obtained from the safety data sheets and labels on the chemical containers. Permissible exposure limits. To help minimize the exposure of workers to hazardous chemicals they work with, OSHA has set limits of the maximum levels of exposure an individual can be exposed and not suffer adverse health effects, which are called Permissible Exposure Limits, or PEL. Exposure limits are published and enforced by OSHA as a legal standard. OSHA PELs are based on an 8-hour time weighted average exposure and can be found in tables Z1, Z2, or Z3 of 29 CFR 1910.1000 on the SDSs or via OSHA.gov. What are some clues that indicate exposure? In some instances, there may be indicators of exposure to chemical hazards. If there is an odor, you can taste the chemical, particles are in your respiratory system, you have acute symptoms, you see visible material in the air, or there is settled dust where there should not be, these may be indicators that you have been exposed. Leave the area, close the door to help contain the material, and contact campus safety. Seek medical treatment immediately if you have been exposed. Exposures. There are two types of exposures, acute and chronic. Acute exposure is short-term exposure and symptoms tend to appear quickly. An example would be a chemical burn to the eye or skin, as seen in the pictures on this slide. Chronic exposure is gradual exposure over time. Symptoms tend to be seen years down the road. An example would be asbestos exposure. Most people do not see the effects of asbestos exposure until 10, 20, or even 30 years after the exposure occurs. That is why it is important to understand what you are working with today, because it could have grave effects on your health years down the road. To reduce the chance of exposure, we need to identify the hazards, receive training, and use engineering controls, workplace behavior controls, and personal protective equipment. We will talk more about these ways to reduce the chance of exposure in the next few slides. Hierarchy of exposure control methods. In this slide, you can see the hierarchy of exposure control methods. The first two methods are elimination and substitution. Elimination is when you eliminate the hazard. In most cases, we cannot completely eliminate the hazard, therefore we move on to the next method. Substitution is when you use different, less dangerous chemicals instead of highly dangerous ones. While these two methods are the most difficult methods to implement, they are the most effective. The next method, engineering controls, removes a hazard or places a barrier between the worker and the hazard. Examples include ventilation systems and machine guards. Using safe work practices and administrative controls helps the worker ensure that they are following guidelines created to keep the worker safe while completing the task at hand. Standard operating procedures and proper housekeeping are examples. Personal protective equipment should be the last method used to control exposure. If you cannot work safely with all of the other methods in place, then you must use personal protective equipment. Examples of personal protective equipment include gloves and eye protection. Personal protective equipment. When all engineering controls and safe work practice and administrative controls have been exhausted, the last option is to use personal protective equipment, or PPE. There are many different types of PPE available. It is very important to choose the correct PPE for the work. A job hazard assessment will be conducted for each position to ensure adequate PPE. The different types of PPE include eye protection, hand protection, hearing protection, foot protection, and respiratory protection. Eye protection includes safety glasses or goggles and may be required when working with chemicals or objects that could cause an impact hazard. Hand protection includes a variety of different gloves for different types of work. Make sure you choose the correct gloves for the work you are completing. Gloves should always be worn while working with any chemicals. Following chemical use, remove the gloves and wash your hands. Hearing protection is necessary when exposed to loud noises for long periods of time and can include earmuffs, earplugs, or canal caps. Steel-toe boots or slip-resistant shoes are examples of foot protection and should be worn when working around potential impact hazards, slippery areas, or electrical hazards. Respiratory protection should only be used when all other options have been exhausted. If you believe that you need to use a respirator, even an N95 or dust mask, alert your supervisor. Your supervisor will contact risk management/environmental health and safety for a job-specific hazard assessment to be conducted. If the respiratory protection is required, the worker must complete a medical evaluation, fit testing, and training prior to using the respirator. Disposal of chemicals. Proper disposal of chemicals is everyone's responsibility. When disposing of an empty container, ensure that the container is truly empty. If the container is held upside down and no liquid falls out, the container is considered empty. Cross out the chemical information on the container using a permanent marker and dispose of the container in the regular trash or recycling. If you have a box that has hazardous materials shipping labels on it, cross these out as well prior to disposal. There are also regulations regarding the proper disposal of chemicals that have not been used up. You should never pour any hazardous chemical down the drain or allow waste to evaporate into the air. This can cause damage to our water system and the air we breathe. If you are questioning whether a chemical is allowed to go down the drain, it probably cannot and should be disposed of as hazardous waste. All chemical waste containers must be labeled and the cap must be on the container unless you are adding waste to the container. We will talk more about managing hazardous waste in the next few slides. Hazardous waste management. So why is hazardous waste management so important? Hazardous waste is highly regulated by the Environmental Protection Agency, or EPA, and specifically the Maryland Department of Environment, or MDE, in Maryland. Waste is considered hazardous when it shows characteristics of ignitability, corrosivity, reactivity, or toxicity, or it is a listed hazardous waste according to the EPA. The listed hazardous wastes include the F list, non-specific source waste, the K list, source-specific waste, the P list, and the U list, discarded commercial chemical products. All of these lists can be found online at epa.gov. Satellite accumulation areas. As we know from the previous slide, hazardous waste is highly regulated by the EPA and MDE here in Maryland. Therefore, there are many regulations and requirements surrounding the collection of hazardous waste for proper disposal. Due to these requirements, we must collect all of our hazardous waste in satellite accumulation areas, or SAAs, that are close in proximity to the point where the user generated the waste. SAAs must be under control of the operator of the process generating the waste and allow the generator to accumulate on site for an unlimited amount of time. However, there are restrictions on amounts. A generator is allowed up to 55 gallons of hazardous waste or 1 quart of acute waste. When that amount is exceeded, the hazardous waste must be dated and moved to the Central Accumulation Area, or CAA, within 3 calendar days. Generators cannot treat, dispose, or store hazardous waste in the satellite accumulation areas. All accumulation areas must have signs stating "Danger, Hazardous Waste Accumulation Area," and all hazardous waste containers must have a label that states "Hazardous Waste" and have the chemical contents and accumulation start date filled in. If you see any of these accumulation areas on campus, it is important not to touch or move any objects from these areas. If you have hazardous waste for disposal, contact Risk Management/Environmental Health and Safety for a pickup to be scheduled. Central Accumulation Area. The Central Accumulation Area, or CAA, for all hazardous waste on campus is located in the basement of Eaton Hall. Just as the SAAs, CAAs must have a sign reading "Danger, Hazardous Waste Storage Area." All containers must be labeled with hazardous waste labels completely filled out, including contents and accumulation start date. All hazardous waste storage areas, the CAA and the SAAs, must be inspected weekly and documented in an inspection log. All containers must be kept closed except when waste is being added to the container. Containers should be separated within the storage area according to the compatibility of the chemicals, and containers should be kept in secondary containment bins on a firm working surface. Ensure that the containers are in good condition to avoid leaks and spills. Universal waste. Universal waste is a subsection of hazardous waste. These types of wastes are widely generated wastes that help encourage the development of programs to reduce the quantity of these wastes going into landfills or combustors. Waste is not considered hazardous as long as it is recycled or treated, not incinerated or landfilled, the substance is not leaking or in a damaged container, and its quantity does not exceed 1,000 kilograms at any one time. Because we can recycle the materials, the regulations allow for certain exemptions when handling universal wastes. If they are not managed properly, they are considered hazardous waste and subject to more stringent requirements. Therefore, it is very important to manage universal waste properly. Universal waste. Universal waste must be separated from regular hazardous waste. The different types of universal waste include used batteries, pesticides, mercury-containing devices, and bulbs, lamps. Universal waste collection must be stored properly in closed containers, segregated by type, and the containers must have labels with the contents and the accumulation start date. The universal waste storage area should be checked weekly to ensure that all regulations are being followed. Laboratory hazard information signs. Laboratories are filled with many other hazards beyond hazardous waste. Therefore, it is important that you understand what you could potentially be walking into when completing any work in a laboratory. Laboratory hazard information signs are posted outside of every laboratory on campus to help warn anyone entering the lab of the potential hazards inside. They are updated yearly or when there is a new hazard introduced into the laboratory, and 24-hour contact information is posted in case of an emergency. Always read the lab hazard information sign before entering a lab. Lab safety. It is important to also understand the rules of the labs prior to working in one. No food, drinks, chewing gum, makeup, lip balm, lotion, etc. are allowed in the laboratories. Using these products while in the lab could easily lead to an exposure incident. Use all required personal protective equipment when working, and wash your hands after you complete the work and before leaving the lab. Report any incidents or issues to your supervisor. While completing work in a lab, be aware of your surroundings. There may be hazardous chemicals or biologicals present, or lab equipment that could be dangerous or fragile. Read all labels and writing on items before you touch them, and if you do not know if you should touch something or if something can be moved, ask before you do. Some laboratories will have signage indicating the presence of biological hazards or radiological hazards. Look for these symbols, as seen on the slide, outside of labs and on materials when working in the lab. Contact Risk Management/Environmental Health and Safety prior to performing and work in the lab that has radiological hazards present. Dress code for entering the labs. Here at McDaniel College, anyone who walks into any lab for any reason must be dressed properly. Regardless of what you are doing in the lab, once you cross the doorway, you must be wearing long pants and closed-toed shoes. This is to ensure you are protected from the potential contamination around the lab. It is important to note that there are more stringent requirements when actually working with chemicals or biologicals in the lab. So let's test your knowledge. What should you do in this situation? If you walk into a laboratory and see a liquid spilled on the floor, what should you do? Should you clean it up? No. Stop work and leave the laboratory. If there are any lab personnel close by, alert them of the spill. If no one is there, contact campus safety. What should you do if you find hazardous materials in the trash? This could include chemicals, syringes, sharps containers, etc. Do not touch any bag perceived to have hazardous substances in it. Contact Risk Management/Environmental Health and Safety for proper disposal. Now let's talk about fire safety and emergency procedures. General fire safety. Make sure you practice good housekeeping in your work areas. Do not overload outlets or block fire extinguishers. Extension cords should only be used for periodic use, not long-term use. Use surge protectors instead of extension cords in your office area. Keep flammables away from ignition sources and know the chemicals and their properties that you are working with. This is a picture of a fire in a laboratory at a different institution. It is important to make sure we work safely within our labs to ensure that this does not become a familiar picture. This is a picture of a fire in an office at a different institution. Housekeeping is extremely important in our work areas to help prevent fires from occurring. Poor housekeeping. Keeping hallways and doorways clear is extremely important. If there was a need for an evacuation in the area seen on this slide, it would be a slow process to ensure everyone evacuated the building safely. If you see a hallway or doorway that looks like this, let someone know. Exiting during an emergency. It is extremely important to know your department's evacuation plan. To exit during an emergency, shut doors in the immediate area. Never use the elevator during an alarm. Evacuate the building using the nearest safe exit and proceed to your designated assembly area for your building. Check in with your supervisor once at the assembly area. Faculty should account for all of their students to ensure they have all evacuated safely. Account for all building occupants is necessary to help the fire department assess the situation and understand if someone is trapped inside. It is important to watch out for emergency vehicles and equipment and follow all directions given by emergency personnel. Emergency procedures involving hazardous materials. In the event of an emergency involving hazardous materials, contact campus safety and risk management/environmental health and safety. To contact campus safety, dial 2202 from any in-house phone or dial 410-857-2202 from any phone. To contact risk management/environmental health and safety, contact Ethan Harden at 410-871-3123. Exposure incidents. If you are exposed to a chemical, it is important to flush the exposed area with water quickly. If you are in Eaton during the exposure, there are emergency showers and eye washes in all laboratory areas. There are also eye washes located in several other areas on campus, including the art studio, photography, the theater shop, and the human performance lab. All emergency showers and eye washes are flushed weekly to ensure stagnant water is not sitting in the pipes when there is an emergency. If you are exposed to a hazardous chemical, inform someone immediately to determine the next step using an SDS or the label. Flush the area with water for at least 15 minutes unless the SDS or the label says not to. This could imply that the chemical will react badly with water. Contact campus safety and risk management/environmental health and safety. You should always seek medical attention following an exposure. Once safe, report the incident to your supervisor. An incident report will need to be completed. Spill response for faculty and staff. In the event of a hazardous materials spill or leak, faculty and staff may be able to clean up the spill. If the spill is under 4 liters, not a highly hazardous chemical, and they have had the proper training, the faculty or staff member may clean up the spill. However, if you do not feel comfortable cleaning it up, do not clean it up. Risk management/environmental health and safety will handle the spill or leak cleanup for you. If you do decide you can clean up the spill, ensure you choose the correct material to clean up the chemical or biological that was spilled and use the correct PPE to ensure you are protected from the chemical or biological. Only clean up a spill if you have the proper training, you have the necessary materials and equipment, and you feel comfortable cleaning up the spill. All cleanup materials must be disposed of properly, and an incident report may need to be completed. Risk management/environmental health and safety must be contacted for all disposal questions and assistance. Spill response over 4 liters. If the spill is over 4 liters or the chemical is a highly dangerous chemical, evacuate the area immediately and remove and notify others who may be in danger. Close the door behind you to help contain the spill, and contact campus safety and risk management/environmental health and safety immediately, who will evaluate the situation and determine the next appropriate steps. Training requirements. As we come to the end of the training, it is important that you understand the training requirements. All employees who work with hazardous materials in a non-lab setting must complete the hazard communication training annually. Employees must receive hazard communication training at the time of initial assignment, annually, and whenever a new hazard is introduced into their work area. For more trainings or further information on safety-related topics, please contact Risk Management/Environmental Health and Safety. You have reached the conclusion of this training. Thank you for participating. We hope you enjoyed it. Proceed to the quiz that follows the training at this time. Please direct any questions or comments to Ethan Harden.